So this crazy looking intermediate is the black box intermediate, and in the presence of zinc or dimethyl sulfide will reduce down such that all of these carbon-oxygen single bonds become carbon-oxygen double bonds. And so on this side, what you end up with is a ketone, and on this side, what you end up with is an aldehyde. Again, what happens is these carbon-oxygen single bonds get reduced down to the carbon-oxygen double bonds. The point to highlight here again is that if you have a carbon with two other carbons bound, that will become a ketone when you reduce this down to the more stable, stronger carbon-oxygen double bond situation. And over on this side, we have a hydrogen bound, so this over here ends up being an aldehyde. If instead you simply add in a much stronger reducing agent, then what that will do is reduce to the ketone and aldehyde and then keep going before you isolate it. So what you actually end up isolating is the alcohols as a result, not the ketone or aldehyde. And at this position, of course, it's a non-selective reduction, so you end up making both. That's a wavy bond right there. And then the hydrogen peroxide, what that does is add another oxygen everywhere that you can. And so here, you can only have 2 oxygens maximum, so the final outcome is going to be a ketone. But on the far end, what you're going to have is a carboxylic acid, which is your highest end oxidation state. Out here, 3 oxygens end up bound, or if you prefer, it ends up oxidizing to the carboxylic acid. So the result of ozonolysis is that a lot of strange things happen along the way, and you end up isolating a really hair-raising looking intermediate. But this intermediate can be reduced in a mild form to ketones or aldehydes, reduced more strongly to the alcohols, or oxidized to the carboxylic acid and ketone variety. And the end result, as I've described it before, is that you have molecular scissors. Anywhere there was a double bond, you end up cutting that double bond and installing ketone or aldehyde, alcohols, or acid and ketone, as the case may be. So you need to know that these are the reagents that allow you to accomplish those transformations, and you need to know that ozonolysis will take any double bond and clip it.